Lecture number 21, alternative energy resources, and in this topic we will be talking about the fuel cell. You might have heard the news nowadays, like the IC engine or internal combustion engine is going to be obsolete in the next like 10 to 20 years, and it is because like there would be more and more electric vehicle that would be actually coming into the market nowadays, market later on. In these electrical vehicle, obviously there would be a motor that would be driving the electrical car, but the power would be provided by the battery. One of the main competitor of these battery is the fuel cell. Unlike the battery, where the charge is stored inside the battery, the fuel cell does not store the charges, but it actually the charges is or are we getting the electric current out of these fuel cells whenever we are supplying the fuel to it. The fuel cell itself is also an electrochemical device which fuel and oxidizer. Normally the oxygen undergoes a chemical reaction, providing the electrical current to the external circuit and produces some power. I would explain this thing on this schematic diagram. So we have got the fuel. So in normally in electrochemical devices, we have got the anodes, we have got the cathodes, and obviously we have got the electrolytes in them. Unlike the as I said, like unlike the batteries where the charges are stored in the electrolytes, the fuel cell does not store the charges, but it actually we provide the fuel to it, and obviously it creates our electrical charges. So what happen in a fuel cell? If we supply fuel into the fuel cell, and for example the fuel is H2 over here, the most common fuel to the fuel cell. Now when the H2 reach to the anode, or when it hit the anode, it would be catalytically converted to ions, which would be H positive ion to H positive ion. And obviously there will be electron which will be actually releasing from this hydrogen. Now the electrolyte, and that is depending on the type of the fuel cell, the electrolyte would either allow the positive ions to move into it, or either it will be allowing the negative ion to move in this example. We have got the positive ion which would be actually at the anodes. So the electrolyte is allowing the positive ion to move from anode towards the cathodes, and it will not allow the negative ions to move through it. So obviously what I'm saying, like the positive ions will be allowed to move while the negative ions will be stopped. Now when the positive ion reach towards the cathode, we would be having some air in, or we would be having an oxidizer. In oxidizer normally we are having the air, and which is having mostly the oxygen. When air in the oxygen when oh, sorry when air in come into the fuel cell, it will again react over here, or catalytically react with the cathode, and then at the cathode it will be reacting with the hydrogen ion coming up, and it will be reacting with the oxygen to give you H2. Obviously this reaction does not look complete, or you say like there is a little bit different thing in this reaction. So what happened at anode? We have got the hydrogen ion moving at this direction, and obviously the electron, which was the negative ions, will be stopped at the anode. Now once the electron is stopped at the anode, we would be providing an external circuit to the electron movement, and this is the place where we would be getting our electric current. So if we provide the external circuit to these electrons, it will be providing us with the electrical current. Now these ions, when reach towards the cathode, it will be reacting with oxygen to make O, sorry, to make the O negative ions. Obviously, that is two negative ions. Now, that's reaction look complete now. Hydrogen ions coming from this direction into electrolyte, while electron coming from the external circuit, giving us the electrical power as well, electrical current as well, and actually reaching towards the cathodes. When it reaches towards cathode, it will actually oxidize, or if I would say like it will ionize our oxygen. Once the oxygen is ionized into negative ions, the oxygen would react with the hydrogen over here, and it will create our, or it will give us our product, which will be the H2O. So it is obviously different from the battery. In battery, we have got the charge store, and that charge is actually moving from the anode towards the cathodes, and obviously from the positive to negative, and or if sorry, the conventionally positive to negative, and once it reached towards the cathodes, it will give us the electrical potential or electrical current. While in a fuel cell, we do not store charges, we only and only provide it with the fuel. So the as far as you are supplying fuel towards the fuel cell, it will give you the electrical output. So this is actually a schematic, or this is what actually the background of the fuel cell. So what actually it's a, like the fuel and oxidizer react catalytically. Catalytically would mean like the anode and cathode does not take part in the reaction, but it actually provide the energy, or it provide the facility to the fuel and the oxidizer to ionize itself. So the fuel and oxidizer, the fuel in, over here was H2 and oxidizer was O2, react catalytically in stages on separate electrode. We said like it was anode and cathode. An electrolyte separating the two electrodes now allow the passage of the ions formed by the reaction. Depending on the type of the fuel cell, as I said over here, the ions may be positively or negatively charged, or the positive or the negative ions would be allowed to move from the electrode, move in the electrode from cathode towards the anode, or anode towards the cathode. Individual fuel cells are connected in parallel and to fire to form the fuel stack to provide the desired output. Now, this is the background of the fuel cell. Now, in today's technology, the fuel which is commonly used in a fuel cell is the hydrogen. It is because it has got the exceptional ability to produce electron when suitable catalysts are used. And normally the catalyst nowadays, the most suitable catalyst nowadays used is as a platinum. While producing and no harmful emission, like in our case, there was no harmful emission, and the only and only product was H2O, which was water. Depending on the type of a fuel cell, methanol, carbon monoxide can also be used as a fuel or oxidizer, and that obviously it has got some performance penalties. It does have got performance penalty, but obviously it is actually a little bit more required towards the fuel alternative, I would say. Um, Now, hydrogen does not occur naturally. It can be produced. It should be produced. Production of hydrogen is either from the electrolysis of the water or chemical reforming of the hydrogen-bearing fuel, which are normally the hydrocarbons. If the reforming or the formation of the hydrogen is separate or outside the fuel cell, it is called as the external reforming. And if it is actually within the fuel cell, it is called as the internal reforming. Uh, if it is external reforming, obviously the hydrogen would be saved or is stored in compressed as a compressed gas or cryogenic liquid or atomic absorbed with the metal structure, predominantly normally the carbon nanotubes. While internally forming refer to application where the hydrogen production or by reforming fuel is integrated within the fuel cell, or might be with what we call it as the fuel itself is made inside the fuel cell. The fuel it is made inside the fuel cell. But owing the limitation, the fuel cell of the fuel cell and electrolyte, the internal reforming of the hydrogen are not normally or normally is possible only and only above 600 degrees centigrade, and that is possible in SOFC, and we will be discussing it in a later lecture. Uh, as we can say, like fuel cell does not operate on any thermodynamic cycle, does not have any thermodynamic cycle, or does not have even any thermodynamic component. For example, heat exchanger, compressor, humidifier, turbine, and no auxiliaries, no irreversibilities. So obviously, it does not work under the limitation of the second law of thermodynamics, or if I would say, like, it does not come under the Carnot limitation. So the efficiency of the fuel cell can go up to 40 to 60%, or even 85%, owing the if you are looking at the cogeneration as well in SOFC. Uh, so it is actually more likely, like, you can get a good efficient fuel cell of more than 60% as well, and normally common fuel cell are 40 to 60%. As it does not have got any uh, harmful, if I say, like, moving part, no harmful emission. So fuel cell is one of the future of any of the automobile industries, or even in the mobile industry, the laptop. So we can use fuel cell in automobile, we can use fuel cell in the mobile phone, we can use fuel cell in the laptops, the stationary power, and so on so forth. There are huge number of uh, possibilities that the fuel cell can be providing us. But despite of its potential thermodynamic advantages and potential, the widespread of fuel cell does not occur so far. But obviously, and again, I'm saying, like, in the next 10 to 15, 20 years, you would be looking at the technology which would be more matured, and you would be looking at the technology like the internal combustion engine, which would be obsolete, and nobody would be trying to use it. There are many type of a fuel cell, and as earlier, depending on the type of the electrolyte, so we are having different type of a fuel cell, like polymer electron membrane fuel cell, PEMFC we call it. It has got a common electrolyte as polymer membrane. It has got the operating temperature of 50 to 100 degrees centigrade, and you can check it like the stack size. If we have got the fuel cell stack size, we can have a polymer electrolyte membrane fuel cell, PEMFC. We can have a PEMFC at 1 kilowatt and 100 kilowatt. It has got the efficiency of 60%, and at the stationary we have got 35%. It can be used in a backup power, portable power, distributed generation, transportation, and specialized vehicle. I've already discussed. It has got some advantages. It has got some disadvantages. And one of the disadvantages of PEMFC is the electrolyte. Sorry, the electrode, which is anode, is normally made of platinum, and that's quite inexpensive. It is very sensitive to fuel impurities, and it has got, let's say, low temperature waste heat. The other fuel cell, or most commonly fuel cell, is SOFC, solid oxide fuel cell. The main electrolyte as would be solid oxide. The temperature which actually would be reaching the reaction temperature, it is around 700 to 1000 degrees centigrade. So it is definitely most good for the internal reforming of the hydrogen. It has got a stack size, if you can check, a stack size of 1 kilowatt to 2 megawatt. It has got the efficiency of 60%, auxiliary power, electric utility, and distributed generation. So in this one, if I would say, like, the SOFC is normally, if it is experimental base generation, so the SOFC is actually right now used in the distributed generation, and it is I've heard the news like the Google headquarter, they are having a generator generating or distribution generation from SOFC fuel cell. It has got high efficiency, fuel flexibility is quite there, can be used variety of catalyst. Catalyst is cheap as well, comparative to PEMFC. Solid electrolyte is used, and we can use by hybrid GT gas turbine cycle as well. I will discuss it later on. Yes, as it has got the high temperature, so we can say like we have got a high temperature corrosion breakdown, high temperature operation required long startup time, and obviously it has got limitation. So it has got its own problem. But SOFC is more likely to be used in the distributed generation of the power, and PMFC that have got more like in if I would say like the summing up the news items. So PMFC is more likely to be used in a portable powers like also like the iPhones or laptops or even the cars. And SOFC is more likely to be used in the distributed generation. But yes, that's what actually a little bit what the research is going on. It might be changed later on. Cooperative effort by government and industry have fostered advances in both proton exchange membrane fuel cell and solid oxide fuel cell, as I've discussed. Uh, Even if I would say like iPhone have also tested their battery, which is actually powered by a fuel cell. So you would be having a iPhone which would be just having a fuel cell. Just you would need to inject, I would say like hydrogen in it, and it will be lasting for another 2 months, something like this. And solid oxide fuel cell, I will say like the Google headquarters, they are actually having an experimental distributed power from SOFC fuel cell. Um, as we have already discussed, type of a fuel cell. So fuel cell have got many varieties, but I've said like the fuel cell type of a fuel cell is what actually the electrolyte define the type of a fuel cell. Uh, Either the electron, either the positive ion would be actually allowed in the electrolyte, or either the negative ion would be allowed in the electrolyte. And obviously, depending on whether it will be polymer, whether it will be solid oxide, whether it would be alkaline. So that means like the type of electrolyte that decide the name of the fuel cell. The fuel is used, and obviously the most common fuel, which is actually, as I've said earlier, that is actually hydrogen. The anode catalyst break down the fuel into the electron and ion. The anode catalyst is usually made up of fine, very fine platinum powder. That is what when we are talking about the PEMFC rather than the other type of a fuel cell. The cathode catalyst turn into the ion into waste chemical like water or carbon dioxide. The cathode is actually quite cheap. It is made of nickel or nano-based catalyst. Um, Owing all these things, the fuel cell is obviously not as simple as we are discussing it. It has got many activation losses. It has got many ohmic losses, like we have got resistance in it. There is actually some even water taking water out of the when the water is formed in the fuel cell. Taking water out of the fuel is one of the major problem. The temperature maintenance is one of the major problem. The catalyst itself is actually get quite expensive. It is one of the problem. So owing these things, the fuel cell, the direction of the research is mostly going towards these different bits actually. The activation loss, the ohmic loss, the mass transmission losses, the temperature losses, and so on and so forth. So, but having said that, fuel cell produce a voltage of 0.6 volt to 0.7 volt. Definitely, it's not that much voltage, so we would be actually combining fuel cell series or parallel, and that's what we call it as a fuel cell stack. The cell surface area can be increased to allow stronger current from each cell in the stack. Reactant gases must be distributed uniformly over all to maximize the power output. So obviously these are different actually I would say like the problem and challenges towards the integration of the fuel cell into the normal electrical vehicle or even the portable powers. Um, Now let's move towards the explaining a little bit of the fuel cell technologies, and we will be talking about two examples. One would be PMFC and SOFC. PMFC, we call it as the polymer exchange membrane fuel cell or proton exchange membrane fuel cell. The fuel cell, as shown in down over here, are called as proton exchange membrane fuel cell, as it is exchanging the electrolyte is exchanging proton from anode towards the cathode. So at the anode, hydrogen ion and electrons are produced, as discussed earlier at the start. Now at the cathode, oxygen and hydrogen ions and electron react to produce the water. The fuel is over here. I've already discussed hydrogen. When hydrogen is actually fused, or if I would say like hydrogen is provided at the cathode, the hydrogen would be splitted into positive ions and the electrolyte. The positive ions will be allowed to move inside the electrolyte, while the negative ions would be barred to go in the electrolyte, but an external circuit or external path would be provided where we would be getting the electrical current as well. At the cathode side, when this hydrogen reach and this electron reach at the cathode side, the oxygen would be actually oxidized uh, uh, or into ions, I would say like, and then these oxygen ion and hydrogen ion would react to make water. So this is the reaction. I hope like you would be able to understand this common reaction. There is another type of PMFC as well. Uh, and that is when actually we are using the humidified methanol as a fuel and oxygen as an oxidizer. In this case, humidified methanol, which is CH3OH, and hydrogen steam would be provided to the fuel to the fuel. At anode, it will be having it will be catalyzed to make 6 hydrogen. If you can just check like 3 over here, 4, 5, 6 over here. So that means like we have got 6 hydrogen ion, 6 electron moving from this direction to this direction, and obviously there would be actually an oxygen which would be coming from the other side, oxygen from the air, and it will be having a reaction at the cathode side, and the overall reaction would be looking something like this, producing 3 molecules of the water. The reaction at these electron and overall reaction are labeled as the figure. The product of this is water, carbon dioxide, and power generated. And obviously, there is actually some waste heat as well. For PMFC, actually, the charge carrying hydrogen are conducted to the electrolyte membrane. For acceptable ion conductivity, high membrane water content is required. You cannot actually leave the fuel cell as dry, and even you cannot leave the fuel cell flooded with the water as well. So there is actually a common, uh, I would say, like a problem with the PMFC, that either it is actually getting too much dry or either it is getting too much flooded with the hydrogen. So typically the operating temperature is maintained at 60 to 80 degrees centigrade. Cooling is generally needed to maintain a fuel cell at the operating temperature. Higher operating temperature would mean like you would be drying the fuel cell, and if you are drying the fuel cell, it also means like there will be no reaction taking place, and obviously there will be nothing. Uh, Owing the relatively low temperature operation of proton exchange membrane fuel cell, hydrogen derived from the hydrogen feedstock must be produced by external, as we have already discussed. Due to now the this is what we call it as PMFC. And if I'm using hydrogen as a fuel cell, so the requirement would be different. But if I'm using the direct methanol, if I was a hydrogenated methanol to it, then the requirement is quite big. What actually I mean, like, at for the direct methanol, it is extremely slow reaction and what we call is as an internally reforming. Uh, and we would need 10 times more platinum catalyst than the normal when we are supplying the hydrogen. So that means like fuel cell itself would be quite expensive, and direct methanol fuel cell, although it looked like we would not need the external reforming, but obviously the catalyst which is used is also the one of the biggest challenges we have got. But having said that, uh, we have got the major contribution in research are from the automakers, many automakers in Japan and United States. The United States, even back like 2 years before, they have got actually taken out like around like 10 to sorry 100 to 200 cars were actually produced using the hydrogen fuel cell, and that's what actually the world is moving. Um, there is also a competition, or there's also the research going on, which would be actually replacing the batteries in the portable devices like cell phone, like laptop computers, or video players. And even I've said like I've seen I've heard the news as well. Like iPhone was actually or iPhone has actually um, experimented on the fuel cell as well. Proton exchange membrane fuel cell issue, we have got reducing cost. As I said, like we would be having a problem in this one. So reducing cost is one of the major problem. Water and air management, temperature management, durability, service life, and so many other issues. That's why we have got huge research going on in this direction. Um, Solid oxide fuel cell, uh, as I've said earlier, the fuel cell depend on the type of the electrolyte. So in a solid oxide fuel cell, we have got the electrolyte, which is actually of the solid oxide, but it is a little bit different than the PMFC, proton exchange membrane fuel cell, or polymer exchange membrane fuel cell. We have already said. Um, in PMFC, the oxidation was at the cathode side, while in SOFC, actually, the reaction is at the anode side. So what happened in SOFC? The oxidizer, again, if I would say like the oxygen in this case, would actually reach over here at the cathode. It will be ionized into O negative ion and the electron. Now, this electron would not actually move towards the later on I will explain again. The electron will not be allowed to move in this circuit, but only and only the negative ion will be allowed from this direction to this direction. At the anode side, the fuel is injected, and the fuel again would be actually ionized into H plus ions. The electron which would be actually available from the oxygen over here would react with the hydrogen over at the anode, and hydrogen and oxygen would be actually reacted at the anode side to produce H2O. In other words, if I'll say like if you can just check the direction over here, it is actually from this side to this side. This is what we call it as the conventional direction of the electrical current, from the positive to the negative, or from the anode towards the cathodes, although there would be actually movement of electrons. uh, Yes, SOFC, I've said like the only product of the fuel cell would be water, the power generated, and waste heat. SOFC alternative fuel to hydrogen can be carbon monoxide. Yes, you can actually react the oxygen ions with the carbon monoxide ions over here, and to produce carbon dioxide. So there would be a carbon dioxide produced, and obviously different other material can be, or the other fuel can be used. Um, as discussed earlier, the fuel cell, SOFC fuel cell, the operating temperature of SOFC fuel cell is 700 to 1000 degrees centigrade. Or in other words, when the reaction is taking place, it produces a temperature of 700 to 1000 degrees centigrade. So SOFC has got the waste heat, and that is relatively high temperature. And obviously, if you can imagine, whenever we got the high temperature, we just want to make it, um, or we just want to harness some heat from it, and that is SOFC can be used to distribute it or power generation of fuel cell, micro turbine generation as well. What we have got a combustion chamber, and combustion chamber which is made of SOFC fuel cell. So the fuel cell itself would be giving us the electrical power. SOFC would be giving us electrical power, and it is producing heat as well. And heat is actually around 700 to 1000 degrees centigrade. From this 700 to 1000 degrees centigrade, we will be passing some air in it, we will be heating up air, and we will be expanding in the gas turbine. So that means like we could have a fuel cell and gas turbine hybrid kind of a system. So this is not what actually I'm proposing. This is what actually the concept is. So replace the combustion chamber and so on and so forth. So we call it as the micro solid oxide fuel cell micro turbine hybrid system kind of a thing. Application of them is power, cogeneration, fuel cell, electrical vehicle, portable power system, and other smartphone application, and so on and so forth. Power and cogeneration is one of the major thing what we can get from the SOFC, power distributed power. I'm calling. Research and development, obviously, huge research and development is actually taking place in terms of fuel cell. And when we are talking about, again, if I'm concluding it, when we are talking about the electrical vehicle, we are not just talking about the battery power vehicle. We are talking about the fuel cell power vehicle. So battery power vehicle have got the future. If, no doubt, like it has got the future, but the fuel cell powered vehicle, they have got a long way to go, and obviously it has got quite a good future. Um, I would suggest like you people just search these terminology or this research, uh, Google it, and you will find many different articles, different topics around it. I would just conclude with this remarks. Like in 2013, British firm ACAL Energy developed a fuel cell that is say like can run 10,000 hours in simulated driving condition. It asserted that the fuel cell cost, construction of the fuel cell cost can be reduced to $40 per kilowatt, which is roughly around for 900,000 for 300 horsepower. So if your requirement at home is, let's say, for example, 2 to 3 kilowatt, so you can imagine for 112, sorry, $120 only, you can have a fuel cell stack. It will be having no pollution. It will be having nothing. It will be having a efficiency, a higher efficiency, and obviously you will be having a electrical energy at your home. I hope you understand this topic. Please make sure, again, I'm saying like you should actually search for the fuel cell in the news as well, fuel cell around the internet, and obviously you will be understanding fully. Thank you very much. Have a nice time.